Now we're looking at the orthocenter, which is the point of concurrency for the three altitudes of a triangle. Remember, an altitude goes from the vertex and then it goes perpendicular to the opposite side. So if we're looking at it in an acute triangle, I'm just going to show you the pictures here. For an acute triangle, here's the triangle, the gray part right here. If we draw one altitude here, one altitude here, and one altitude right here, the orthocenter is right here, and it's inside the triangle for any acute triangle. For a right triangle, here is one altitude, here's another altitude, and the third altitude is here. So for a right triangle, the orthocenter, which is P, would be actually on the actual triangle. And finally, for this triangle right here, can you see the gray right there? This gray one right here. If we extend this altitude beyond the outside of the triangle and extend this altitude, remember it'll be outside the triangle in this case, so that it goes to here, and this altitude for this side right here, we have to extend this and extend it out. The orthocenter for a obtuse triangle will end up being outside of the triangle, like that. Alright, and now we want to prove that the median to the base of an isosceles triangle is an altitude. Basically, all we need to do here is prove that these two angles are congruent. If these two angles are congruent and they're also supplementary, then that means that this is a 90-degree angle and it's an altitude. So we already know that these two sides are congruent and those two sides are congruent. So we have ABC is isosceles, and we know that BD is the median of the base, therefore these two parts are congruent. We want to prove it's an altitude. So right now, what we can state is we can state AB and BC are congruent by definition of isosceles triangle. We can state that AD is congruent to DC because of the definition of a median. We can also state that BD is congruent to BD because reflexive property. Therefore, the two triangles are congruent by side, side, side. And then we would state that these two angles, BDA and BDC, are congruent. We can also state that they're supplementary, and if they're supplementary and congruent, they have to be right angles. So let's see what this would look like. And if they're right angles, then it's an altitude. So we start off with legs AB and BC are congruent because it's isosceles. We would say CD and AD are congruent because BD is the median and BD is congruent. Again, there's our side, side, side. Now, these two angles are congruent because of CP-CTC. We can also say that they're a linear pair. Since they're a linear pair and they're congruent, then they form perpendicular lines. And since the lines are perpendicular, then we know BD is an altitude of ABC. And it says to copy the triangle in example 4 and find its orthocenter. I'll just show you what that looks like. Here is the triangle. It's an obtuse triangle. So again, we would extend this side out. This is also an altitude right here. We would continue this to here. Actually, what we'd do is we'd say the altitudes are here. Let me do that a little bit darker or bigger. So we would say one of the altitudes goes from here to here. One of the altitudes for this side goes from here to here, and the third altitude goes from here to here. And the reason why is because with obtuse triangles, we have to extend this side out, and we have to extend that side out. So then what you'd do is you'd notice that this point, and this point don't cross, so you have to extend it even further, and even further, and then you'd find out the orthocenter is right there. And what if we wanted to show that median BD is an angle bisector? We would have to prove it a little bit differently, but all you'd have to do is, if we go back to the picture, the original picture, what we'd have to do is state that angle ABD is congruent to angle CBD because of CPCTC, and therefore it's an angle bisector. That would be the only difference, and it would actually be easier. So again, we'd do that by side, 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 and then we'd state that those two angles that I showed you were congruent, so that makes BD an angle bisector. And it says triangle PQR is isosceles, and segment OQ is an altitude. What else do we know about OQ? And what are the coordinates of P? Well, if we look at this, one way we could do this is we could make the isosceles triangle so that, here's the picture right here. We know it's isosceles because this length and this length are equal. Therefore, the coordinates of P should be the same distance here but in the opposite direction, so it would be negative h, 0. And what else do we know about it? It's an altitude. We know it's an angle bisector. We also know that it's a median because these two lengths would be equal. Okay, so it's a perpendicular bisector, an angle bisector, so those two angles would be equal, and it's also a median. And that's it. Thanks.